Look up at the night sky. Countless stars twinkling like cosmic jewels spread across the vast emptiness of space. Some are young, still forming in great clouds of gas and dust. Others are ancient, burning through their last reserves of fuel before collapsing into dense remnants. But what if I told you that astronomers have discovered a star so old, so mysterious, that it defies everything we thought we knew about the universe? This is the story of SMSS J031300-36 670839.3, a star so strange that it's forcing scientists to rethink the very origins of stars, galaxies, and even our own existence. Located in the halo of the Milky Way, this unassuming celestial body appears to be one of the oldest stars ever found, an ancient relic from the dawn of time, a cosmic survivor from an era when the universe was still young. But there's a problem. A paradox so profound that it has left scientists scratching their heads. According to everything we understand about stellar evolution, this star should not exist. It is missing one crucial ingredient, iron, and that makes it one of the most baffling discoveries in modern astrophysics. A journey to the beginning of time. To truly grasp why this star is so extraordinary, we need to go back, way back, to the very beginning of everything. The universe as we know it began 13.8 billion years ago, with the Big Bang, an unimaginably violent explosion that created space, time, and the building blocks of all matter. In the first few minutes after this cosmic event, the universe was a chaotic, searing hot soup of fundamental particles. But as things cooled, the very first atoms began to form, primarily hydrogen and helium, the two simplest and lightest elements. For millions of years, the cosmos remained shrouded in darkness, filled with nothing but this primordial gas. But then something incredible happened, the birth of the very first stars. These stars, known as population 3 stars, were unlike anything that exists today. They were gigantic, pure, and incredibly short-lived, fusing hydrogen and helium at unimaginable rates. Because they formed directly from the aftermath of the Big Bang, they contained no heavier elements, no carbon, no oxygen, no iron, just the raw materials of the early universe. These first-generation stars burned furiously for only a few million years before their massive cores collapsed in spectacular supernova explosions. When they died, they created and scattered heavier elements, iron, carbon, magnesium, into space, seeding the cosmos with the essential ingredients for the next generations of stars and planets. Every star that came after them, including our sun, the planets, and even the atoms in your body, was formed from the remains of these first stars. This means that every known star in the universe today contains at least some traces of iron, except for one, the mystery of SMSS J031300-36670839.3 discovered by astronomers using the Sky Mapper telescope in Australia. SMSS J031300.36670839.3 is 13.6 billion years old, almost as old as the universe itself. But what makes it truly bizarre is its near-total absence of iron. In fact, the amount of iron in this star is so low that it is almost undetectable, at least 10 million times lower than the Sun. This makes it one of the most chemically primitive stars ever discovered. It's as if it was born directly from the ashes of the very first stars, untouched by the heavy elements that normally appear in later generations. But here's the problem. This star shouldn't exist according to our current understanding of astrophysics. If it formed after the first stars exploded, how did it end up with so little iron? Shouldn't it have absorbed at least some of the elements released in the aftermath of those powerful explosions? A supernova, unlike any other. One of the leading explanations is that SMSS J031300-36670839.3 formed from the remains of a very unusual first-generation star. Instead of a typical supernova that spreads a wide range of elements into space, its predecessor may have experienced a low-energy explosion, one that released a massive amount of carbon and magnesium, but almost no iron. This type of explosion, known as a fallback supernova, is extremely rare. In this process, most of the iron and other heavy elements are pulled back into the collapsing core of the dying star, preventing them from being dispersed into the surrounding gas clouds. This means that when a new star formed from this material, like SMSS J031300.36670839.3, it would contain almost no iron, while still having other lighter elements. This theory, if confirmed, would completely rewrite our understanding of how the first stars lived and died. It suggests that some of these early stars may not have exploded the way we thought. Instead of scattering their elements evenly across space, some may have trapped their heaviest elements within their cores, leaving behind a chemical fingerprint that we are only now beginning to decode. A glimpse into a lost era studying SMSS J031300 36670839.3 is like peering through a cosmic time machine. It provides a direct link to a time when the universe was still young, when galaxies were just beginning to form, and when the laws of physics were still shaping the cosmos as we know it. But this discovery also raises even bigger questions. If this star exists, how many more like it are out there? Could we find even older stars, ones that hold secrets even closer to the birth of the universe? And what does this tell us about the first galaxies, the first planets, and even the origins of life itself? Scientists are now on the hunt for more stars like SMSS J031300 36670839.3, hoping to uncover even more clues about our cosmic past. But with every new discovery, the mystery only deepens. Challenging the foundations of astronomy, the discovery of SMSS J031300 36670839.3 is more than just an anomaly. It challenges some of the most fundamental principles in modern astrophysics. For decades, scientists believed that after the first generation of stars exploded, their heavy elements mixed thoroughly with interstellar gas, ensuring that all subsequent stars contained at least some traces of iron. But this star seems to defy that rule. So what does this mean for our understanding of stellar evolution? Could it be that the first stars weren't as uniform as we thought? Or, an even more radical idea, could this suggest that we have overlooked an entirely different process of star formation that occurred in the early universe? Astronomers have begun looking for answers using the most powerful telescopes on Earth and in space. Instruments like the James Webb Space Telescope, JWST, and the Very Large Telescope, VLT, are helping scientists analyze the light from extremely distant galaxies, some of which formed less than 1 billion years after the Big Bang. These observations could reveal more stars like SMSS J031300 36670839.3, helping us understand whether it is truly an outlier or part of a broader, unknown phenomenon, the hunt for population 3. Stars. Perhaps the most exciting implication of this discovery is that it could bring us closer to finding the legendary population 3 stars, the very first stars to ever exist. These stars have remained elusive because they lived short, violent lives and were likely destroyed billions of years ago. But if SMSS J031300 36670839.3 is a second-generation star formed directly from the ashes of one of these ancient giants, then it serves as a direct fingerprint of that lost era. Scientists believe that if we can find even more stars with ultra-low iron content, we might be able to reverse engineer the properties of population 3 stars, uncovering details about their size, temperature, and how they ultimately met their fate. This could redefine our understanding of how the first galaxies formed, how elements spread through space, and even how the building blocks of planets and life itself were created. Could this star be even older? One of the most controversial debates, sparked by SMSS J031300 36670839.3, is whether it is actually older than we think. Officially, astronomers estimate its age to be 13.6 billion years, just 200 million years younger than the universe itself. But some researchers have raised a shocking possibility. What if this star is even older than our current models allow? Some radical theories suggest that the first stars may have formed earlier than expected, even within the first 100 million years after the Big Bang. If true, this would completely upend our timeline of the early universe and force scientists to reconsider the speed at which galaxies and structures formed. And then there's an even wilder idea, one that sits at the edge of mainstream astrophysics. Some theorists propose that SMSS J0311-300-36-670839.3 could be evidence of an entirely different era of star formation, possibly linked to exotic processes from the earliest moments of the cosmos, such as primordial black holes or even physics, beyond the standard model. While these ideas remain highly speculative, they highlight just how mind-bending this discovery is. A single star has raised questions that reach into the deepest mysteries of existence. What comes next? Scientists are now working on several key missions to uncover more about this mysterious star and others like it. The next steps involve using the James Webb Space Telescope to analyze distant galaxies for signs of similar ancient stars, conducting high-resolution spectroscopy to detect trace amounts of iron and other elements in SMSS J031300-36670839.3, which could reveal more about its formation, simulating the first supernovae using advanced computer models to see if low-energy explosions could really create a star like this. The more we study stars like this, the more we realize how little we actually know about the early universe. Each new discovery pushes the boundaries of human knowledge, bringing us closer to answering some of the most profound questions of all. Time, where did we come from? How did the first stars form? And what else is out there waiting to be discovered? The final puzzle, what this means for the universe SMSS J031300-36670839.3 isn't just an old star, it's a cosmic anomaly that has forced astronomers to rethink long-standing theories. Its existence challenges our understanding of the universe's earliest moments and suggests that something fundamental may be missing from our current models of stellar evolution. If stars like this one exist, it means the earliest supernovae may not have been as powerful as we thought, or that the process of element formation was far more complex than our models predict. This single discovery has opened a floodgate of new questions. Could there be even older stars hiding in the Milky Way, remnants of an era we never thought we could glimpse? Are there yet undiscovered forces at play in the formation of the first stars? And perhaps most intriguingly, could this be a sign that our understanding of the early universe is incomplete? The next steps for astronomers involve pushing our telescopes and computational models to their limits. The James Webb Space Telescope, JWST, is already providing unprecedented views of the early universe, allowing scientists to study galaxies that formed within the first few 100 million years after the Big Bang. If JWST finds more ultra-metal-poor stars, or even the elusive Population 3 stars, this discovery could become part of a much larger cosmic mystery. But even if no other stars exactly like SMSS J031300-36670839.3 are found, its existence alone is enough to reshape astrophysics. It tells us that the first generations of stars may have formed and evolved in ways we never expected, and that the cosmos still holds secrets we can't yet explain. This discovery also reminds us of a profound truth. The universe is far more mysterious and complex than we ever imagined. Every time we think we have a complete understanding of how things work, the cosmos throws us a curveball, challenging our assumptions, forcing us to question everything we know, and pushing the boundaries of human knowledge. So what do you think? Could there be even older stars hidden in the vastness of space, waiting to be found? Or is this a one-of-a-kind cosmic relic that will forever remain an enigma? Let me know your thoughts in the comments, and if you enjoyed this deep dive into one of astronomy's biggest mysteries, don't forget to like, share, and subscribe for more mind-blowing discoveries.